This picture is taken from Montgomery Statistical Quality Control. I'm going to show you how to create these probabilities in Excel. Um, if when the process is centered with some targeted mean value, imagine that we want to produce a cup of coffee at 180 degree Fahrenheit. So that would be our target mean value. And then if it's one standard less, two standard less, and this is how the normal distribution curve look like. So if we have a coffee machine that only can make sure that it only produce coffee within one standard deviation, then how many cups of coffees will be within the specification? That is 68.27%. And rest about 32% will be out of specification. We call non-conformance. Let's open a Excel file and then create that calculate that probability. So to calculate between in Excel probabilities, there is a function called norms dist. Before we write that function, I would like to create the range of areas that we are interested to calculate the probability. So we are looking at between plus minus 1 sigma, 2 sigma, all the way to 6 sigma. So if that is our specification limit, I would like to make these cells wrapped in text, so I get some more space to work with. And I would like to call that lower spec limit, and then upper specification limit, and then area before the lower spec limit and area before the upper spec limit. If we get this area in Excel, we can calculate area, cumulative area. So let's assign these numbers, this standard deviation: 1 minus 1, 2 plus 1, and then between, if your machine is capable to produce between two standard deviations, so plus minus 1 to minus 2 to plus 2, and then we want to see all the way, assume that we have a machine that can produce up to 6 sigma standard. So let's go. Now to calculate area, there is a because we are using a normal standard normal distribution, we'll explain later in probability section what's the difference between standard normal and just regular normal. In this case, we are using a standard normal. In Excel, the function for a standard normal is norms dist. I would like to type this in capital letters, that because it's easy to see, but this is not case sensitive, so you can type anything. So norms dist, we are interested in calculating area in the under the normal distribution curve up to -1. So this function will give you area all the way from the left side up to -1. As you know, normal distribution, it never touches x-axis, so it's kind of flattened out. It goes all the way to infinite. Now I can copy this cell and it will calculate probability for corresponding values. So this will calculate up to -2, this will calculate up to -3, and so on. And then we can calculate the area before 1, so equal same thing, norms dist parentheses, choose the value. This will calculate all the way up to 1 from the left side up to 1, and then copy that all the way down. Then we are interested in between -1 and +1. So if we subtract this value from this, then we can get the area. Now I would like to go back to that picture again, the one from the Montgomery Statistical Quality Control. This is also Besterfield book 2. You have the same pictures. I just have a access to permission to use this picture, so I'm using this. So we calculated, when we write normstist 1, it gives you -1. It gives you all this area before this point 1. And then when we wrote normstist 1, it gives you all the area before this line. Now we want to calculate, if you want to calculate between -1 and +1, then we can subtract all this area before from all this area before +1. This will give the 68.27%. Let's go back to Excel. Let's find out. So this should be equal to 68.27. As you can see, probability is within 1 in Excel. In Montgomery book is expressed in percentage. So percent conformance. So we have a machine now that can only produce up to standard deviation between 1. So if we want to see out of 100, we can multiply by 100. That will give us the percentage value. So every 100, 68.27 product will be within its specification. So non-conformance would be, now if you want to calculate the percent non-conformance, we can get equals 100. So if 68.27 within conformance out of 100, then non-conformance will be 100 minus this value. Now I copy all the way down. As you can see, the numbers are too small. If we have a machine that can produce up to 6 sigma standard, this is 1.97, so I can see only 2% out of a 10 million product will be defective. So typically this percent non-conformance is expressed in typo here. It is typically present in percent non-conformance in parts per million. So non-conformance per million. In that case, we have to multiply this with 100,000. So this equals this times 1000 and then 0, because we already multiply by 100. So as you can see here, only 0.002 out of a million will be defective if we can ensure things in 6 sigma standard. Now let's go ahead and calculate process capability for each of this machine. It is expressed using CP, capital C, small p. The formula for process capability, I'm going to show you right now. So that's the formula for process capability. Upper specification limit minus lower specification limit divided by 6 sigma. This is based on 6 sigma standard. That's why it's divided by 6 sigma. So our machine is producing, when we say between one standard deviation. So that would be equals upper minus lower, close the parenthesis, divide by 6, divide by standard deviation 1 in this case. Let's do this way. And you copy all the way down so for each of these cases, the process capability is for the machine that can produce only within one standard deviation, its process capability is only 33%. 1.33 is the recommended. If anything goes lower, then you go further investigation, things like that. All right, so that's it for a centered process. Centered process, non-conformance or conformance calculation. So I would like to call these the centered process non-conformance calculation. I'd like to go back to that Montgomery picture again to show you what we have actually done. So this is what we have calculated. In addition to that, I calculated the process capability. In the Bester field book, it has that column 2, and also Montgomery later discussed that.